Borehole problems are the problems where we'll be talking about how to find out when we have done a borehole in the ground and we got certain hard rock formation on which our foundation will lay down. Okay, such foundations are there and we want to go for further depth, or probably we have three borehole data among after processing of calculation we want to go for the more number of boreholes. How to do that, this part will be studying in borehole problems. Okay, so here what will happen is the first problem directly we'll be solving here. The reason behind that we don't have any theoretical part, we'll be using part of our data which we have already used. That data is nothing but our what do you call it as dip and strike problems. We'll be solving using the dip and strike problem as the information. So let us read the problem. There are three test boreholes which are drilled at the apex of an equilateral triangle. So this is more important. When they say apex of an equilateral triangle, means we have an equilateral triangle whose all three sides are same, as well as all three angles are also, internal angles are also same. XYZ. So they have given us the information with respect to the directions of these boreholes, where these boreholes are located, and all that information they are given over here. Okay, and in that they said X is north 30 degrees east of Y, and here they said Z is south 30 degrees east of X. So let us plot first initially a rough diagram which will give us this information. So imagine I'll consider one point as my a random point, and I'll draw north south east west line. I'll drop here a north south east west and a small one, because this is just for the understanding purpose. Okay, this is my north line, arrow indicates a north line. Okay, so it is understood this side is north. Okay, this side ultimately becomes south, this becomes east, and this becomes west. Okay, so I'll erase this. It is understood. Now what they say, X is north 30 degrees east of Y. So this I'll consider this point as my point Y. I'll consider this point as my Y, and I will plot north 30 degrees east. North 30 degrees east means it will come in this quadrant. Say for this is my north 30. I am drawing a rough diagram here. So I'll say this. I'll say this is my north 30. And this is my point. Okay, this is my point X. This is my point X. Okay, so now this part is over. Now they say Z is south 30 degrees east of X. So this point again I will plot a north south east west line. I'll plot north south east west line, and here this is south 30 east they said. Okay, so I'll plot south 30 east here. South 30 east here. So this has become my point Z. Again I join this. So this becomes my X, Y, Z points. This becomes my X, Y, and Z points. Okay, so this is first part is over. Then say the sides of the equilateral triangle are 450 meter long. They said it is 450 meter long. So this is 450. This is my 450. This is also my 450 meter. So these all three sides are 450, 450, 450 meters. Okay, and as it is an equilateral triangle, it is understood that this is 60, this is 60, and this is also 60. It is understood. All three sides are same, means it is understood it is all 60, 60. What the next part, a limestone bed is encountered at depth 20, 70 and 110. So, and they said respectively. What do you mean by respectively? X is 20 meters, Y is 70 meters and Z is 110 meters or 110 meters. So all three beds they are given and we'll be plotting that part also. Next, they said determine. So given data is over now. Within this we completed the given data. So determine attitude of the limestone bed. What do you mean by attitude of the limestone bed? The attitude of limestone bed is nothing but we have to find out true dip direction and true dip amount. These two things we need to calculate. So here we'll be taking the help of our dip and strike problems. We'll be taking the help of dip and strike problems. What we studied here in dip and strike problem, we can find out the true dip direction as well as amount, provided we have certain other data. Then we can surely find out the true dip direction as well as amount. And what is that maybe data? True dip direction and amount we need to find out means we need a data for apparent dip. Let us convert whatever the information is given. Let us convert that into the apparent dip. How that we will do? First of all, we'll plot a depth diagram. How the depth diagram is? Okay, let us say this is I will plot here the depth diagram. I'll just explain what I mean by depth diagram. Okay, so this is my ground. This is my surface ground. Here, this point, I'll plot a smaller one. This is the smallest one. Okay, I'll extend it. And this here, the point comes, which is largest one. Okay, so we have three boreholes. One is with the lowest value, another is bit higher up to that, and then we have highest one. So what we'll do, we'll take a lowest value at the center. Say for 20 meter is the lowest one. So we took that as at the center, and we'll name this point as point X. Okay. Second highest, we'll take it on our left hand side. How much? 70 meters. We have 70 meters. Okay. And this is my point Y. And we have the largest one as 110 meters. That is my Z. I'll plot it in this much side. Now I'll make them join at the center. This and this. I'll extend it a bit. Okay, now we need to find out the gradient for this. The slope, the gradient we need to find out. So we'll be finding out the gradient from X to Y and X to Z. X to Y and X to Z will be finding out the gradient. Okay, so how to calculate the gradient for X to Y and X to Z is we have a formula. That formula is the gradient of X to Y we can calculate based on the difference between the depth of the boreholes divided by the distance between the two boreholes. So we have two boreholes, that is X and Y. Okay, X and Y will take the depth. So 70 minus 20 divided by the distance between two boreholes is 450 meters. Distance between two boreholes is 450 meters. The value comes around 0.11. So we will be calculating the gradient. So I will be doing 1 by 0.11. We get the value as 1.9. We get the value as 1.9. In the direction, how much? South 30 west. How we calculate the direction? That is the direction from X to Y. They have given a direction from Y to X. We have to find out the direction from X to Y. How? See, this is the center point. This angle is 60. This angle is 60. Okay. So 30 is gone here. This side 30 is over here. So south 30 west. So on that basis we calculated as south 30 west. We calculated as south 30 west. Okay. So now when we calculate south 30 west, okay, we understood that we got one direction and one amount. Same way we'll calculate the gradient from X to Z as well. We'll calculate the gradient from X to Z also. Okay, so how will we be calculating? The same. we have depth 110. We have depth 110 minus 20 divided by 450. 0.2. We got the answer as 0.2. So 1 by 0.2. 1 is 1. 1 is to 5. In which direction? South 30 east. How? Because we have x to z, they are already given the direction. South 30 east we calculated. Okay, so this is, with this we got two amounts. We got two amounts and two directions. We got two amounts and two directions. Okay, so let us remember this, write it down, these values, so that we can jump to the next slide. Values are 1 in 9 in south 30 west and 1 in 5 in south 30 east. Okay, so we'll move to the next slide and we'll try to solve the attitude of the bed first. Okay, now let's take the values from the back side and let's continue to solve the problem. Okay, so it says we have recorded that gradient of x to y is 1:9 in south 30 degrees west, while x to z is 1:5 south 30 degrees east. This we have taken it from the previous slide. Okay, now let us start solving the problem. Okay, so first of all I will draw north, south, east, west line. Okay, this is north, south, and this is my east, west line. Okay, so I'll name this as north, this is south, this is east, and this is west. Okay, now let us start plotting what we have. So we have first south 30 degrees west. Let's plot south 30 degrees west. So I'm measuring this angle. I'll be measuring this angle, south 30 west. Okay, this is say for this is somewhat around 30 degrees. Okay, and angle is how much? Amount is 1:9. So I'll write down here south 30 west and amount is 1:9. Okay, so this we are plotting from the point x. So let's name that as x. I'll change the color. This is x and this will be my point y. Okay, now let us plot south 30 east. So this is my south 30 east and my 1:5 will come somewhere here. Same way I'll write down here south 30 east and 1:5. Okay, and name this as z. I'll name this as z. Now let me join these 2 points. Let me join these 2 points. So this is my first point and this is my second point. Okay, I will erase it. I'll try it once again. Okay, so this is my point, this is my point, and this is my second point. So sorry, this is the point. Okay, somewhat correct. Same way I'll shift that point here also. Parallelly I shifted this. So now what we got? We got straight line. we got straight line. Okay, so whatever data was been given, we already plotted the data. Now we are left with the true dip amount and direction. How we will be plotting true dip amount and direction? That we know this, we can plot a perpendicular here. Okay, so my perpendicular will be somewhat like this. My perpendicular will be somewhat of this kind. Okay, so this will be my perpendicular line. Okay, and I name that as A. Now what you do to calculate the true dip direction and amount? You measure this angle, okay, and you measure the distance XA. You measure the distance XA and measure the angle SXA. So according to me, the values will be 1:5, and this will be south 26 degrees east. Sorry, south 26 degrees east. Okay, so this is the true dip amount and this is true dip direction. So we completed with the first part, that is attitude of the bed. Now we have second part. Okay, so this part is completed. The part of calculating the true dip and apparent dip is been completed. Okay, so this will give you the true dip amount that comes around 1:5, and we have true dip direction also that comes around south 26 degrees east. Okay, so this part is completed. Now we are remaining with the next part, that is the depth of the fourth borehole. So they say this is the second part. They say a depth of the limestone is proposed at borehole M located at 750 meter due south of X. So due south of X they said. So they said from the X point somewhere on the south line, okay, we have another borehole which is 750 meter, and that borehole name is M. The borehole is M. Okay, so that is at 750 meter. So how to calculate the depth of the limestone as proposed borehole M? Okay, so there is a formula called as fourth borehole is equals to 1 by G into df plus dl. Okay, so the gradient G means, here I'll write down what is the meaning of G is the gradient of the fourth borehole. Gradient of the fourth borehole. df is nothing but the distance of fourth borehole, and dl is the depth of least borehole. Okay, so this all data is available with us now. Okay, let me give you the things. So the gradient of the fourth borehole, where is the gradient? The fourth borehole is located on the south line. Okay, so wherever this point is cutting, I'll name this point as M dash. And I'll measure the distance. So according to me, the distance of this is 5.5 into df, depth of the fourth borehole. Sorry, distance of the fourth borehole. How much is the distance? 750 meters. Plus the dl is nothing but depth of the least borehole. How much is the depth of least borehole? So the least borehole is x. Okay, so the depth of that is 20. Okay, so now if you solve it, you will get answer as 153.93 meters. 153.93 meters is the correct answer. So this will give you the depth of the fourth borehole. Depth of the fourth borehole. This is how the problem number 1 ends here. Okay, we will see the second problem. So second problem says that a proposed reservoir area, a limestone bed, is made by 3 test boreholes. P is north 30 degrees east of Q, R is due east of Q at an apex of an equilateral triangle. Again we have equilateral triangle here, and with the sides of 600 meters and depths as 75, 141 meters, 42 meters respectively. Same thing they are given, we need to calculate the things. Okay, now let us understand the problem first. Let us take one point. Okay, let us take one point and we'll plot this thing. I'll take it properly. We'll take it at the corner so that you can utilize the entire space. Okay, I'll draw here. This is feasible problem again, so I'm drawing it here. Okay, so this is my north, this is my north, this is my south, this is my west, and this is my east. This is we can draw it in this fashion. Okay, so this is my point, one point. I'm not saying is which point is this. So P is north 30 east of Q. So this I'll consider as my point Q. I'll consider this point as Q, and from here I am drawing north 30. Okay. So I am drawing north 30 I'm saying north 30 east. Okay, so this is my north 30 degrees, north 30 east. Okay, now this is my point, this is my point P now. Okay, now what this is, R is due east of Q. They said R is due east of Q. So this is my point Q. On the east, due east means I say somewhere here my another point is there, that is my point R. That is my point R. What I'll do now? Now I'll join these 2 points. This point and this point. This is coming here. Oh, sorry. This is my point R. Now what happened? This is 30. This angle is 60. This is 60. This is also 60. Internal angles. These are internal angles. Okay. Now you understood this. North 30 east Q and R is east of Q at apex of an equilateral triangle. Okay. Now here these sides are 600 meters. This is 600 meters. This is 600 meters, and this is also 600 meters. This is also 600 meters. So all sides are 600 meters. Then at a depth of 75, 141 and 42 meters respectively. So when they say respectively, it is like this one is 75 meters, P Q is 141 meters, and R is 42 meters. R is 42 meters. Okay, so now what we will be doing is we'll be plotting the depth diagram first. We'll be plotting the depth diagram first. How will we be plotting the depth diagram? Like this. Like previous only, we'll be plotting the depth diagram. Okay, so this is our depth diagram. Bit higher, the lowest and the highest. Okay, so here the lowest borewell point will come at the center. So lowest borewell point is 42 meters, and that point is nothing but our point R. Okay, while second lowest is 75 meters, that point is nothing but P, and we have another one 141 meters, and that point is nothing but Q. So I'll join this and this. Yes, good. So now we need to calculate the gradient for R to P and R to Q. R to P and R to Q gradient will be finding out. How will be finding out? Let's see. I'll write down here the gradient P to R. The value will be 75 minus 42 divided by 600, and you may get some answer. Okay, let's write down the direction as well here. So direction of P to R, that is already being given. Okay, so how will be calculating P to R? Okay, so that P to R, I'll draw a north south east west line here. Now this is 30, right? This is 60. We'll be intersecting at the center. So this angle will be taking, that is south 30 east. South 30 east will be the angle. Okay, you need to calculate these angles. Now another one we have R to Q, and that is 141 minus 42 divided by 600. While the direction for this is R to Q. This is Q to R is due east, so R to Q will be due west. R to Q will be due west. Okay, so due west. Okay, so this is actually, this is something wrong. R to P. Oh, sorry, this angle is not correct. It should be R to P, no? R to P. So this is here. Instead of here, I should draw a north south east west line at this point. Okay, this is my north. So R to P will be north 30 degrees west. North 30 degrees west. And answers you have already: 1 in 16, 1 in 18, and 1 in 6. 1 in 16, 1 in 18 and 1 in 6. One is north 30 west, north 30 west, and another is due west. Okay, so let us solve this problem in next slot. Next slot we'll see, next slide we'll see how to solve this problem. Okay. Okay, done. So first I'll write down the gradients. I'll write down here as R to P as 1:18 north, 30 west, and 1:6 due west. Okay, so this is the gradients. Now I'll draw north, south, east, west line first. North, south, east, west line. I'll draw this line on the lower side. Okay, so this is my north, this is my south, this is my east, and this is my west. This point is O. Okay, so north 30 west will be plotting first. So north 30 west comes in. Change. This is 30 degrees north, 30 west. Amount is 1:18. It may or may not fit in your paper. You can reduce the scale. You can reduce the scale always. Okay. So this is my 18 point, 18 degree. Or if you cut it one in, if you change the scale, you may get it as 1:9. And then we have another is due west. So my due west comes here on the west line itself. So I'll name this point. This is my point R. Okay, and this is my point P. Okay, same way this will be 1:5 we said. Sorry, 1:6. So say for 6 will come here. This is my point Q. This is my point Q. Now what I'll do is I'll join these points. I'll join these points. This point and another is this point. Okay, and parallelly I'll shift that line here also. Okay, now if I put a perpendicular line to this, I'll change the color. Okay, if I put a perpendicular line to this, this will be something of this kind. Perpendicular line will be this kind. This is my 90 degrees. I'll name this as, say, for A. You measure this angle. Okay, and measure the distance RA. So true dip, if I say true dip direction, if I measure, that comes around south 79 or 80 degrees west, and true dip amount will be in the range of 1:5.8. 5.8. Okay, that is nothing but the distance RA. This is distance RA, and this angle is S. Angle SOA. Angle SOA. Okay, so this will give you the results for the true dip. Now the next part, that is a depth of the limestone at station S, which is north 60 west. at R, north 60 west at R. So north 60 west, I'll be plotting first. First thing what I have to do is, after this calculating this part, we have to go for the fourth borehole. And how will be getting the value for fourth borehole? Say this is the fourth borehole. I'll write down the formula once again. That is 1 by G into dF plus dL plus dF. So first we need to calculate the gradient. Now where the first fourth borehole is located? It is located north 60 west. So first plot north 60 west. Let us plot first the north 60 west. I'll take this north 60. Say for this is 45 around. This comes to be 60. This comes to be 60, and that point is named as S. So you measure the distance OS. This is north 60 west. You measure the distance OS. So according to me, the distance is 7.8. This will come as 7.8. 1 by 7.8 into df. Df is nothing but the distance of the fourth borehole, that is given already, that is 800, plus dl is depth of the least borehole. Which is the least borehole? R is the least borehole, and that distance is 42. So let us solve this. You will get answer as 144.56 meters. 144.56 meter is the perfect answer for it. Okay, so hope you understood this. You solve this problem. Now let's see the problem number 3. So what it says, 3 test boreholes. Number 1, earlier they used to give X, Y, Z, ABC something. Here they have given number 1, number 2. Number 1 is north 30 degrees east of number 2, and number 3 is east of number 2. So drill an apex of equilateral triangle 750 meters sides in a river bed intersecting a conglomerate. Conglomerate is in a rock. Okay, bed at 80, 90 and 30 meter respectively. So here the same thing we need to calculate. Let's see how to solve this problem. So initially first I will take one point. I'll mark one point. Okay, I'll say this is my point, and I'll check. So number 1 is north 30 east of number 2. So I'll consider this as N2. I'll consider this as N2, and from here I will draw the line. Okay, so I'll first of all plot north south east west line here. Okay, and from here I will mark as north 30 east. Okay, say for this is my north 30 east, or sorry, it's become too large. North 30 east. So here comes my borehole number N2. I'll say N2. Okay. Fine. This is no, sir, not N2. It's N1. This is my N1, and this is my number 2 borehole. Now where is the number 3? Number 3 is east of number 2. So from this point, it is located in a somewhere here at east direction. Okay, located here in the east direction. So join this. Okay, and I'll name this as my borewell number 3. Borewell number 3. So this is again, this will become 60, this will become 60, and this also will become 60. Okay, we have north, south, east, west lines at all corners. Okay, north, south, east, west lines at all corners we have. Fine. So let's see what are the angles they given. They said 750 meter sides, equal sides. 750. This is 750 meters, and this is again 750 meters. Okay, and they said the depths as 80, 90, and 30. So this becomes 80 meter. I'll again change color. This becomes 80 meter, N2 becomes 90 meter, and N3 becomes 30 meters. So this is the primary data we have. Now we'll plot depth diagram here. We'll plot depth diagram here. Okay, so my depth diagram is depth diagram. We will plot it. Okay, so we have the middle line. Okay, we have shortest line here. We have larger line at this corner. Okay, and now the least depth is our 30 meters. Least depth is 30 meters. Okay, so I'll plot 30 meter. Least is 30 meter, and value for that or is N3. Then we have another next level as 80 meters, and 80 meters, and the value for that is N2. And then we have N1 with, this is 80 is N1, and we have N2 as how much? N2 as 90 meter, which is the highest. Now again I will join this. Let us find out the gradient for N3 to N1 and N3 to N2. Okay, so this will be the gradients I need to find it out. Now how will you find out the gradient? So N3 to N1. Its formula is already been explained in the first column. So 80 minus 30 divided by 750. 80 minus 30 divided by 750, and that comes around 1:50. Now directions are important. N3 to N1. How much? So here I will plot north, south, east, west line. This is 60. Remained is this is becomes 30. So north 30, west. We got north 30 west, and then we have N3 to N2. That becomes 90 minus 30 divided by 750. The answer for this is 1:12.5. Now N3 to N2, so this will be due west, So we got these values We got these values. With this, we'll start solving the further problem. Okay. So further problem, first let us write down. In simplified manner, I'll write down here. N3 to N1 is 1:15 in direction. How much? North 30 west, and we have N2 N3 sorry to N2, that is 1:12.5 due west. Okay, so this is the things which we have right now. Okay, now let us plot the north south east west lines. Let us plot the north south east west lines. So this is my north south. This will become my, I'll take mid bottom. This will become my east. So I'll mark this north, south, east and west. Okay, now whatever is been given, let us plot that. So we have north 30 west in the beginning. So let us plot north 30 west. North 30 west comes around like this. We have north 30 west. So here this becomes, we are drawing N2 to, this becomes N3, and this, the point 1:15 I am marking. Okay, I am marking 1:15. Just a second, this line should be a bit on the upper right because it is 30 degree, no? This is 30 degrees. So this will become my, this is N3, this becomes my N1, and the direction is north 30 west. Amount is 1:15. You can change the scale if you want. Another is on due west, so on the west line itself. So west line, say for this is my marking. So this becomes my N2. This becomes my N2. Okay, just a second, I'll take it inside so that this becomes my N2. Now what I need to do is I need to join both these lines. Okay, I need to join both the lines, this and this. This line and this line. Perfect. I'll change the color so that you will understand. I'll say I'll take red itself. I join this line. Okay, parallelly I'll shift at this point also. Parallelly will shift this point also. Now what happened? We got the answer, or we got the straight lines. We got straight lines. Now if you drop a perpendicular to this line, we will get the information about the true dip direction and amount. So probably something of this kind will do. If we consider this line, so from here it will fall. So this will be my perpendicular line. Okay, I'll make 90 degree at this point. I'll name this point as A. Now you measure the distance N3 to A, you will get a true dip amount. You will get true dip amount, and that true dip amount you will get somewhere around 1:11.8. Then you make this, measure this angle. You measure this angle. Okay, so that comes around north 68 west. Okay, this is your true dip direction. This is your true dip direction. Okay, so all over you got north 68 west. North 68 west. Now this is first part is over. Now let us see the second part. Second part is the depth of the fourth borehole. Depth of the fourth borehole. Okay, so what they say, a depth of conglomerate at station number 4. Apart from these three, there is station number 4, which is the midpoint of 1 and 2, which is the midpoint of number 1 and number 2. So midpoint of number 1 and number 2 comes somewhere here. Midpoint of 1 and 2 is comes somewhere here. Let us join this 1 and 2. Let us join this 1 and 2. So this is over here. This is my number 4 borehole. Okay, this is my, here there is a number 4 borehole. Now we have a formula already. Known formula is depth of the fourth borehole. Fourth borehole is equals to 1 by G into dF plus dL. So what is G? G is the gradient of this distance you measure from this point till N4. This distance you measure, that comes around 12 into dF. dF is how much? They are given 650 meters. They said 650 meters plus the depth of the least borehole. Least borehole is 30. Okay, that is N3. So this, if you calculate, you will get 84.16 meters. You will get answer as the depth of fourth borehole is 84.16 meters. This is your final answer. So by this way we completed both the 1 and 2 problem. Okay, 1 and 2 sub question from the problem number 3. Okay. So let's see the fourth problem. So fourth problem, the problems are similar way, but there may be a slight changes which we will observe and we will solve the problems. So it says that a damp site limestone was struck by 3 test boreholes A, B, C at an apex of triangular grid. So they are not said as equilateral triangle. Till now whatever problem we solved, there everywhere the word called equilateral triangular grid was there. Here the equilateral triangular grid is absent. Okay, so they have simple triangular grid. Now they said A to B is south 55 west and with a distance of 600 meter. A to C is south 30 east with 800 meter distance. So you can see this difference is there in the sides. Okay, the distance wise, the borehole to borehole earlier this to be same says, here there is a change. So they said A to B is this much and A to C is this much. But one thing which we observed is A is the common one. A is the common one. Let's consider that common one. Let's consider that common one and start plotting the diagram. Okay, so the first one, let's consider the common point as A. Let's consider the common point as A. We'll consider the common point and we'll name this point as our point A. We'll name that point as our point A. Okay, next. Then let's plot the dimensions. So they said south 55 west. So here south, this is the south direction, this is the south direction, this is the north direction. Okay, south 55 west. I'll plot south 55 west. Okay, see, I must create a problem or confusion. South 55 west, and that point I'll name as B. South 55 west, that point I'll name as B, and distance is 600 meters. Distance is 600 meters. Okay, then we have south 30 east. A to C is south 30 east. 30 means it will come like this. That is, and I'll name this point as my point C, and the distance here is 800 meters. Distance here is 800 meters. Then I'll join this. I'll join this. This makes a triangular grid. This makes a triangle. Now let's see what another part they are given. They are given us the depths of the borehole. They said 35, 155 and 180 meters respectively, means A, B, C. So A is nothing but 35 meters, B is 155 meters and C is 180 meters. C is 180 meters. Okay, so this is what they have given us for the calculation part. Now let's see how to plot this. Now immediate after this, as usual, we'll be plotting the depth diagram. We'll be plotting the depth diagram. Let's see this point. Let's consider. This is our ground surface. Then we'll take this as one point, center one with lowest point, and the last one with the highest point. Okay, now let's plot it again. Let's take the values. Okay, so take the values. Okay, I'll use this color. So center, the lowest depth will be taking at the center, and that is 35 meters, and name of that point is A. The second dip will take on our left hand side, that is 155 meters, and that point is nothing but our B, while the last one, that is 180 meters, and that the point will be C. Now what I'll do, I'll join these points here and here to here. So we have to calculate the gradient from A to B and A to C. A to B and A to C will be calculating the gradient. Okay, so these two things will be calculating the gradient. How will we calculate the gradient? Okay, so we'll start with A to B. A to B. Okay, so A to B, the depth distance, that is 155 minus 35 divided by the distance about A to B is 600. Distance between A to B is 600. Okay, now this comes around 1:5. And what will be the direction? Direction already they given. A to B is south 55 degrees west. Okay, now another gradient is A to C. Another gradient is A to C, and that is 180 minus 35 divided by 800 is the distance. So we get that as again 1:5.5, with the direction they are given A to C as south 30 degrees east. South 30 degrees east. Okay, so we got two directions and two amounts we got for A to B and A to C. Let us move ahead by solving the another set, or the let's solve the first part of it, that is attitude of the bed, where we will be talking about true dip direction and true dip amount will be calculating, which completes the attitude of the bed. Okay, let's move to the next slide. So here I'll just take down the previous data, that A to B is how much? 1:5, south 55 degrees west, and A to C is 1:5.5, south 30 degrees east. South 30 degrees east. Okay, so let's plot the diagram itself. Thus we'll be taking out the east west, north south east west line first. Shift it here. This is our north south, and this will be our east west line. Okay, I'll take that as north south and east west. We'll be taking out these values. Then let us plot these amounts, directions. South 55 west. We will first plotting south 55 west. How will be plotting? This is our point, south 55, right? This comes out 45 and 45. South 55, and amount is how much? 1:5. So I'll say this point as 1:5, and this point is nothing but our point B. This is our point A. Okay, same way I'll be plotting south 30 east. South 30 east, and the amount is 5.5. okay, so this point become my point C. Now first thing what I'll do is I'll join these 2 points. And parallelly I'll shift it to the point O also. Okay, now so this completes, this plots our straight line. Whatever data has been given we already plotted. Now we'll be plotting the true dip from this. We are plotting the true dip. So the true dip somewhat comes around, so I'll be plotting a perpendicular line, so that makes a 90-degree angle. I'll write down here as our true dip. I'll write down here again, here it is true dip. Okay, so now once the true dip is been presented, now we are left with the, we'll calculate this distance A to TD. Will get true dip amount, and if you measure this angle, we'll get, if you measure the angle SATD, then we'll get true dip direction. So according to me, the true dip amount comes around, 1:3.8, while true dip direction comes around south 16 degrees west. comes around south 16 degrees west. Okay, so this is what I received it after solving. Okay, now let us see the part B of this problem, and the part B is nothing but, or this is nothing but a depth at which the same limestone bed is met at fourth borewell D, the fourth borewell D, which is at 700 meters south 40 west of A. South 40 west of A. This is at south 40 west of A. So first of all, what we need to do is we need to plot south 40 west. We will plot south 40 west first. Okay, so approximately south 40 west. Okay, once you plot south 40 west, name this intersection point as point D, the fourth borewell D, you name it. Now we already know the formula for it. That is, the fourth borehole is equals to 1 by G into df plus dl. So now how to calculate this? We have G gradient, that is nothing but distance AD. We'll be calculating the distance AD. I calculated that distance as 1 by 4.2 into df is nothing but the distance, that is 700 is already given, 700 is the distance, plus dl, the dl is nothing but the least borewell, that is the point A, and that is the 35 depth. So you get the answer as 201.6 meters. This is the answer. So once you solve this, you will get this answer. Now you can solve the problem. In similar fashion, we will solve the problem number 5. Okay, so 3 test borehole. R is south 30 degrees east and P is south 30 degrees west. So usually they used to give R, P, Q, something like this, but here they have given only R and P. So let's assume that there is another third borewell is Q. Okay, are drilled at the apex of equilateral triangle, which is having 500 meters side in a construction site, met with a sandstone formation at 60, 20 and 40 meters respectively. So we'll have to determine as usual true depth of the sandstone bed as well as the depth of sandstone at point C, which is 725 meters due south of Q. Okay, so this we need to calculate. So let's start. Let us say I'll consider one point as my point Q, and I'll plot the 30 meter south 30 east and south 30 west on the either side. I'll plot south 30 east, and in the same way I'll plot south 30 west, south 30 east. Okay, on either side I'll join this. I'll say south 30 east becomes my R and south 30 west becomes my P. They have distance as 500 meters on both the sides. 500 meters on both the sides. Okay, so this is what given. Then they have given a depth. Okay, respectively they said. So R is 60 meters. Respectively they said. So P becomes 60, Q becomes 20 and R becomes 40 meters. Okay, so these three, let us plot the depth diagram. Plot the depth diagram. Here we have this, then we have this, and the largest one, So So the lowest one is 20 meters. Lowest one is 20 meters. So I'll this name as Q. The second highest is 60 meters, and that is distance P. And the last one, sorry, R. Just give me a second. R, and the last one is P, that is 60 meters. Okay, so now I'll join these 2 points. And I will let us find out the gradients for Q to P. I'll change the color. Gradient for P to Q, that is 60 minus 20 divided by 500, and that comes around 60 minus 20 is 1:12.5, and they have already given the direction for Q to P is south 30 degrees west. Given the direction south 30 degrees west. Similarly, we will be finding out for Q to R, that is 40 minus 20 divided by 500, that comes around 1:25, and the direction is already given south 30 east. So this data will carry forward to the next slide and we'll try to solve the problem. Okay, so I'll write down here P to Q. We have 1:12.5 south 30 degrees west, and again Q to R is 1:25 south 30 degrees west. Okay, so this is the given data. Now we will plot that diagram here now. Okay, so this is my north, this is my south, this is my east, this is my west. Okay, so now I have the center point. Now I'll plot first south 30 east. Sorry, I did not written this properly. 25 is east. I'll plot first south 30. This makes 45. So 30. So 30, and again I have another as south 30. Okay, so I'll name this is south 30 west and this is south 30 east. Okay, so this point is my point Q, this point is my R. So here I'll mark 12.5. Okay, I'll mark this point as 12.5 and name that as P. And another I have is another point I'll mark, that is the 1:25. Mark is here and name that as point R. Now let us join these 2 points. this point, and this point, and this point. Okay, fine. And parallelly I should join the point O also. Okay, now let me plot a perpendicular this will be my perpendicular which is 90 degrees, which is 90 degrees. So I'll name that as TD. So if you measure the distance Q to TD, if you measure the distance Q to TD, okay, you will get the true dip amount, and according to me that comes around 1:12.5. And if you measure this angle, that is true dip direction, that comes around south 30 west. So actually you get these two lines on the same point. Okay, you get these two lines on the same point. Just because here I missed drawing it, so you get these lines at the same point usually. Okay, so now let us think about the second part of it, the problem. That is a depth of sandstone at station C, which is 725 meter due south of Q. Due south of Q. So here due south of Q they said, so where the straight lines are intersecting, that point I am marking and naming that as point C. Okay, then we have a formula, that is fourth borehole is equals to 1 by G into dF plus dl, and G distance is nothing but Q to C. Q to C if you measure, and that distance comes around 14.2 into dF is 725 plus dl dl is the least borehole, that is Q point, that is 20. So you solve this, you get the answer as 70.34 meters. 70.34 meter is the answer for it. Okay, so you solve this and complete your journals. Same way, there are another three problems are given. Okay, so in the problem number 3, instead of mentioning the X, Y, Z or PQRS, they are given this borehole number 1, borehole number 2 and borehole number 3 they have mentioned. Here also in the fourth borehole they are not given the distance. So they said this is the fourth borehole is at the midpoint of borehole number 4 and borehole number 1 and borehole number 2. So what you have to do, once you plot it, you should measure the distance between borehole number 1 and borehole number 2 after plotting the dip and strike problem. Okay, you have to measure the distance between borehole number 1 and 2 and divide at the center, drop that line with the least borehole and get that distance at the depth of the fourth borehole. And the answers are also mentioned for your information. Same way in the fourth borehole, fourth problem, here there is no need to draw the first triangle diagram. Here they are given directly. There is a distance triangular equilateral triangle. A to B is this distance and A to C is this distance. Okay, it is not equilateral triangle, which is actually should be scratched out. It is a triangular grid. Okay, it should be mentioned as triangular grid. AB is north south 55 degrees west, and the distance between A to B is 600 meters. AC is south 30 degrees west. This is 800 meters. So here directly you can draw the here you can directly draw the diagram and the depth diagram, because here the directions of AB and AC is given. So the least borehole becomes A to B and A to C directions are given, and the depths are given. So you can find out the gradient and calculate the depth of fourth borewell. Okay, same way in the fifth problem also in the similar fashion you can solve. So if you to download these problems or to download this soft copy of these problems, you can visit my web page to get the more information. Also, if you have any doubts or any clarification, the details are mentioned in the last page. You can contact me or you can drop me a mail at sagarwag at 481@gmail.com. The link and the email address is mentioned in the description. Okay. Thank you.